Yeah, today we'll discuss about initialization of a structure variable. Okay, so like ordinary variables, a structure variable can also be initialized. What is initialization? That means giving values at the time of declaration is called initialization. Okay, so for ordinary variables, we have seen how to initialize a variable. Okay, similarly, structure variable can also be initialized. A structure variable can be initialized like any other variable because it is also a variable. It can be initialized. Okay, so example, if I want to define a structure for storing the details of a book, assume. Okay, so then I define a structure name book in this way. Okay, so define a structure for book using the keyword structure and structure variable name book. Okay, so then what values I want to store? Title of the book I want to store. So then I define a member char title of size 30. Then I want to store number of pages. Then I define a member called as int pages. Then I want to store cost of the book. That means I define a member called float price. Then end this structure definition with semicolon. Okay, so then I can define a variable in this way, struct book B, and directly I can supply the values here is equals to by using assignment operator. Now you see here struct book B equals to. We said that this structure definition does not create any variables. No memory is allocated for any of these members. We said the members themselves are not variables. Okay, so when we define a variable like B here, struct book B, now memory is allocated and you can now initialize the values in this way. Okay, so B equals to, use the assignment operator because you are supplying more than one value. You must enclose the values in braces, left brace and right brace. Okay, so then you supply all the values for the members defined. So first one is a title, then I give the name of the book as letter C, comma, then number of pages 425, then price 545.75. Okay, so then the memory for B is allocated and these values are stored in those memory locations. Okay, so this is how we can initialize a structure variable. Okay, so directly supplying the values at the time of declaration. Now, the second way of declaring initializing a structure variable. Okay, so you can define the structure in the same way, struct book, char title, into pages, float price, and at the closing brace, after the closing brace, directly you can give the variable name here. Okay, so you can write the variable name B equals to and you supply the values here, then finally end this with a semicolon. Okay, so then that means you are defining the structure and at the same time declaring a variable and initializing its values. This is also allowed in C language. So what is the advantage here? In the first method, you need to define the structure variable separately. See here, struct B, struct book B is equals to. So that means the entire structure name you need to define again. Okay, so then supplying the values here. Okay, so instead of writing again in a separate line, you can define the variable here itself at the closing parenthesis. Okay, and then declare the variable name and supply the values. So, and finally, you should end this with semicolon. This is also allowed. Okay, so we can follow any one of these methods based on our choice. So let us write a program to demonstrate initialization of a structure. Okay, so simple C program will write where we can initialize a structure. Okay, so first line is write the comment program demonstrating structure initialization, then include the header file hash include stdio.h within the angle braces, include this header file. Now define the structure for which you want to store the details. So I want to store book details here. So that's why I'm defining a structure called as a book, struct book, and what members you want to store, and you define all the members inside this structure. So I want to store book title, pages, and price. Along with their data type, you define these members. And finally, end the structure definition with a closing brace followed by semicolon. Okay, so then define the main function, and inside the main function, now you declare a structure variable. So like this, struct book B equals to. Okay, so this variable, structure variable B is called structure variable here. So the structure variable definition you must declare inside this main and supply the values within the braces here. Okay, so let us see and see here. Let us see is a string here, so that's why you must enclose in double quotes. Okay, comma, then price pages integer 425 and price 545.75, close and end with a semicolon. Okay, so when you initialize the structure variable B, the memory is allocated in this way. Okay, so for B, memory is allocated, and let us see is stored. Now see, the memory contains three parts. Okay, so the first part, second part, and third part. So in first part, let us see will be stored, and in the second part, 425 will be stored, and in the third part, 545.75 will be stored. And we know that this entire block of memory is accessed by using the single name called B. Okay, so what is the name of first part? The first part name is title. What is the name of second part? Pages. What is the name of third part? Price. Okay, so if you want to access these data, let us see 425. How will access? We access by using this variable and the member name. B dot title indicates, let us see, B dot pages. If you say that indicates the value 425, and if you say B dot price, it indicates 545.75, the value 545.75 it indicates. Okay, so this way the memory is allocated for B, and these values, initialized values, will be stored in this memory locations. Okay, so what is the total memory allocated for B? Now B is the structure variable here. Okay, so what is the total memory allocated for B? It is nothing but sum of the memory for each member. Okay, so for first member 30 bytes, for second member 4 bytes, and for third member 4 bytes. So total how much memory is allocated? 38 bytes of memory is allocated. The memory allocated for B is 38 bytes. Okay, so now once the values are stored in memory, now we can access these values and we can print these values onto the monitor. Okay, so after initializing the structure variable, now print the values of details of a book. Okay, so using printf, just you print the heading book details. You can use some designing here. Okay, so you can use some symbols here so that on screen it displays with this design. Okay, so I'm just printing book details heading. Okay, so then book title is equals to, okay, so book title is string 1, so that's what percentage yes, comma, how can I access? B dot title. I can access the value B dot title. Similarly, printf number of pages is equals to integer, so use format specifier percentage D, then comma, how can I access? B dot pages, I can say. So then next book cost is equal to, so cost is a floating point 1, so percentage F, and how can I access? B dot price. See, in the structure variable, in the structure definition, we have given the member name as a price. Okay, so that's why you have to use B dot price here. Okay, so then finally say return 0, close. Okay, so this way you can demonstrate by using a simple C program where we can initialize a structure variable. Okay, so sometimes in examination this will be asked directly. Explain about initialization of a structure or structure initialization with simple program. Okay, so these things, if you describe and if you write simple program like this, then it would be nice. Then you should keep some rules in mind when you are initializing the structures. Okay, so just see here, we cannot initialize individual members inside the structure template. Okay, so in the structure definition, directly we cannot pass a values. Okay, so example struct book. Now see, char title is equal to, let us see, int pages is equal to 425, float price is equal to 545.75. Okay, so this you cannot say. This is wrong. This is wrong way of initializing the structure members. Okay, so we said that structure members are not variables themselves. So that's why you cannot initialize them inside the structure definition. Okay, so this is wrong way of initializing a structure. Okay, so then how you can initialize structure? In previous example program we have seen. Okay, so that means you need to create a structure variable like this struct book b, and here you need to pass the values. Okay, so this is the correct way of initializing a structure, and this is wrong way of initializing structure members, please remember. Okay, so next the order of values enclosed in braces must match order of members in the structure definition. Okay, so in the structure definition you are defining first title, then pages, then price. In the same order the values must be supplied. Example, just see here. So structure first title you have defined member, next member is pages, then next member is price. Okay, so then you can supply the values in this order. First title, that means first a string, then followed by an integer, then followed by a floating point. It expects data of these types. First a string, integer, and float. Okay, so you should supply the values in this three same order. Okay, so this is correct way of supplying the values or initializing structure members. Okay, if you supply like this, say for example, struct book, char title, int pages, and float price, and if you supply the values b is equal to, first pages you are supplying, then title you are supplying, and next price you are supplying. Okay, so but this gives error because first it expects a string and you are supplying an integer which are not matching. Then second it expects integer and you are supplying a string which is also not matching. Okay, so that's why it gives error. Okay, so this is wrong way of initializing a structure variable. Please remember. Okay, so the order of values supplied should match with the members defined. It should match with the members defined. Okay, so you should take care of these things when you are initializing a structure variable. Okay, next, array of structures. Okay, so for example, I want to store employee details. Okay, so then I define an employee structure like this. Say struct employee char name of 20. I want to store employee name and his age. Then I define a member int age, then his salary. Okay, so float salary member I define. Then end this definition with a closing brace followed by semicolon. Okay, so this is employee structure where I can store employee details. Okay, so if I want to store one employee details, then what I do, I create only one structure variable in this way. Struct employee e equals to, okay, so name is something like ABC, age 42, and this is his salary. Okay, if I want to store another employee, then I can define one more variable, structure variable here. Okay, but we want to store 100 employees details. Okay, so in an organization there may be hundreds of employees. Okay, so assume that some 100 employees details I want to store. Okay, so in such case we cannot create 100 structure variables. Okay, so what we can do is we create an array of structures. We create an array of structures. We said that array is collection of homogeneous elements when 100 employee details. Okay, so when there are large number of same data to be stored, then we use an array. Okay, but in this array what we are storing? We are storing structures. That means employee details we are storing. Okay, so that's why this is called an array of structures. Array of structures. Okay, for example, just see here. Now if I define int something like x of 50, then end this with semicolon. Okay, so here this x is called array. X is called array, okay, which is going to store 50 integer numbers. So that's why this is called array of integers. This is called array of integers. X is called array of integers. Okay, so similarly here, if I define an array where I can store 100 employees details, then that is called an array of structures. Okay, so how it can be defined, just see here. So now I can define struct employee e of 100, e followed by square brackets, and within the square brackets how many employees, 100 employees details I want to store. Now this e is called array of structures. No doubt, e followed by square brackets will say array. Array of what? 100 employees. Okay, so array of size 100, and each element of which type? Struct employee type. Okay, so each element is of structure type. So that's why it is called an array of structures, e of 100. Okay, so how memory is allocated for this e? Okay, so that is very, very important. Okay, so here e is an array of 100 elements where each element is of type struct employee. Okay, so that's why we call E as an array of structures. Now, if you look into the memory diagram of E, now like this, 100 locations memory will be allocated for E in this way. Okay, and this entire block of memory is accessed by using the single name E. Okay, so you know how to access individual members of array. So first element will be accessed as E of 0, then second element E of 1, third element E of 2, next element E of 3, next element E of 4. Okay, so like this, the last element can be accessed like E of 99. E of 99. Okay, so this is an array of 100 elements, but each element is what? Each element is a structure type. Okay, so if you see this first box, E of 0 box, it is not a single box here. Okay, so it is again divided into three parts like this. Okay, so E of 0 is divided into three parts like this. If you exaggerate this and see the diagram, okay, so E of 0 again contains three parts like name, age, and salary. Okay, so E of 0 indicates first employee details, E of 1 indicates second employee details, E of 2 indicates third employee details, E of 3 indicates fourth employee details. Okay, so like this, each employee details we are going to store in this array. Okay, so E of 0 memory diagram, if you expand, then again the single box is not a single box, it is divided into three parts like this. So first part is name, second part is age and salary. For example, same E of 1 also contains name, age, salary. E of 2 also contains name, age, salary. E of 3, if you expand, similarly name, age, salary will be present in this E of 3. Okay, so that means each box is again divided into three parts in this way. Okay, like so E of 99 represents what? 100th employee details. E of 99 indicates 100th employee details. Okay, so this is how we define an array of structures. Struct employee E, and within the square brackets size, okay, 100. Okay, now E is called an array of 100 elements where each element is struct employee type. That's why we call E as an array of structures. Okay, now this is the memory diagram. Okay, so how it can be used in a program, C program, if you want to use, how it can be used. Simple program will write for demonstrating a array of structures. Now just include the header file. Okay, now I'm defining the employee structure, struct employee with three members like char name of 30, int age, and float salary. Then end this definition with the closing brace followed by semicolon. This way. Okay, so this is employee structure definition. Okay, now define the main function. Okay, so we need to store different employees, 100 employees details. So that's why we need a loop here. So I'm defining a loop control variable I here. Okay, so what I do is I store only 3 employees details. Okay, because to demonstrate by using a memory diagram, it would be easy for me. Okay, 100 employees details means then it is time consuming. Okay, so if I want to store 3 employee details, okay, so then I define an array of 3 employees like this, struct employee E of 3, and directly you can initialize the values. Now see here, open brace followed by these are the first employee details. So all first employee details again enclosed in a braces. Okay, so first employee name, age, and his salary. Then similarly put comma afterwards, comma. Then you can initialize second employee. Okay, XYZ, comma, age, and his salary. Then third employee details, something like PQR, comma, 45, and this is his salary. Okay, then finally close this with closing brace and end with a semicolon. This is initialization. You can even initialize a structure, array of structure also. Once you know structure initialization, even array of structures can also be initialized like this. Okay, so E of 3 means contains 3 elements. That means 3 employees details. Each employee again contains name, age, and salary. Okay, so like this. This way, you can initialize 3 employee details separately, or you can just remove all these braces, open and closing braces. Only thing is the first open brace and closing brace you can use and supply 9 values in a row. Then one-to-one mapping will be done and these values will be stored in a array of structures in this way. Okay. Now see, E of 3 I initialized with 3 employees details. So how much memory is allocated and how the memory is allocated for E and how these values are stored in E. If you see, now see. Now E contains 3 elements. This is red part is E of 0 and this blue part is E of 1 and this green part is E of 2. Now 3 elements are there. How each element is accessed? First element E of 0, second element E of 1, third element E of 2. Again, the first element is divided into 3 parts like name, age, and salary. Okay. So up to red part, this is first element divided into 3 parts. Then similarly, second element again contains 3 parts, name, age, salary. Similarly, third element again contains name, age, and salary. Okay, so just observe how the details are stored here. In E of 0, the first name ABC 35, 1234.50 will be stored. And in E of 1, the next employee details like XYZ 40 and 5678.5 will be stored. And in the green part, E of 2, the third employee details will be stored. This is how we initialize. Just see here, E of 3 is equal to, we supplied the values in this way, and ABC, XYZ, PQR, 3 employees. Okay, so then those values will be stored in memory, and memory is allocated as a row. Please remember here. Okay, so memory is allocated as a single block here. Then E of 0, E of 1, E of 2 details will be stored in this fashion. Okay, now the question is how to access individual members of each element. Okay, so if you remember, say this is E of 0, name, age, and salary. Okay, so how it can be accessed? How it can be accessed? Now, if you consider the diagram, now E of 0, I am just drawing only E of 0 containing 3 parts here. Okay, so this is name, this is age, and this is salary. Okay, and this is E of 0. Okay, so how this name field is accessed here? ABC, if you want to access this name, how it can be done? Okay, so this is nothing but E of 0 dot structure member is accessible by using dot operator. E of 0 dot name will say. Okay, so then this gives the value ABC. Okay, similarly age, if you want to access this, how we will access here? E of 0 dot age. Okay, so how we access this salary field? This one, E of 0 dot salary. Okay, so the same dot operator we use here. Okay, but only thing is we combine here array notation and dot operator. Okay, so combined together, and then the individual members will be accessed here. Okay, so once you know how to access individual members of array and how to access individual members of structure, both can be combined in array of structures. E of 0 dot. Similarly, how we can access first employee, second employee, E of 1, E of 1 dot name, E of 1 dot age, E of 1 dot salary. Okay, so similarly, E of 2 dot name, E of 2 dot age, E of 2 dot salary. Okay, so this way 3 employees details we can print. Now after initializing, after initializing the 3 employees details like this. Okay, so then this is how the memory is allocated and the values will be stored. Now we'll print onto the screen. Okay, so by using a simple for loop for I is equal to 0, because array indexing begins with a 0. So I is equal to 0, I less than 3, because I am going to store only 3 employees details, then I plus plus. Now just you print here heading each employee detail. See, employee percentage D details, comma I plus 1. So I value is 0. 0 plus 1 means 1 will be printed. That means on the screen you can see employee 1 details. Okay, so then name, age, salary will be printed. So after that I plus plus, I becomes 1. 1 less than 3. Then you can see employee 2 details, name, age, salary. Then similarly employee 3 details. Okay, so this way all the 3 employees details will be printed onto the screen. Okay, so how we can access each employee name, age, salary? Now see here, E of I dot name, because 0, 1, 2 we are storing in variable I. Okay, so that's why here you have to use E of I dot name, E of I dot age, E of I dot salary. Okay, this way each employee I is equal to 0 means first employee details. Okay, so E of 0 dot name, E of 0 dot age, E of 0 dot salary. First employee name, age, salary will be printed. When you say I plus plus, I becomes 1. So employee 2 details will be printed here. E of 1 dot name, E of 1 dot age, E of 1 dot salary, like this. Okay, so we'll see the execution of this program so that you can understand. Let me start code blocks. So let me copy this. Okay, so then I can print each employee details in this way. Now see, this printf I have included inside the for loop. Okay, because each employee details I want to print and the message to be printed every time. Okay, so let me save the program. So what is this? Array of structures, no? Array of okay, so let me save the program. Now the program is saved. Okay, so this is alignment is missing. Okay, so let me these 3 details, E of 3 now contains, I am printing the details here. Okay, so let me compile the program. I am building the program. Now you can see there is an error employee here. Okay, so what is that error? Just see here, stray undefined xyz, these things. Okay, so because I copied from ppt this program, so these double quotes are in a different fashion, so that's why you change all the double quotes here. Okay, so these double quotes creates the problem because this editor and our pointer. Okay, so uses different style of writing the double quotes. Okay, so that's why we are getting this error here. change all the double quotes. You can see the color change when I am changing these double quotes. Okay, so now again build the program. Okay, so this time no errors. Directly I initialized the values. Here you can also enter these values through keyboard. Okay, right? So to keep things simple, I initialized the values here. Okay, now you can see here directly this for loop is executing and employee 1 details. Okay, name ABC, age and salary it is printing. Then I becomes a 1. Then employee 2 details it is printing. Okay, XYZ 40 and this is the salary. Okay, so then I plus plus 2 employee 3 details it is printing name PQR age and the salary. Okay, so like this 3 employees details I am printing in a separate lines. Okay, so this is simple example for array of structures. Both array concept and structure concept we are combining to store more number of employees details, even more number of student details, book details. If you want to store there, we use array of structures concept. Okay, hope this is clear. Okay, right. Then structures within structures. Structure within structures. Okay, so that means you can define one structure in another structure, and the concept is called as nested structures. As we defined one if statement in another if statement, and there we called nested if statements. Similarly, structures can also be nested, and it is allowed in C language. A structure within another structure is known as nested structure. Okay, so one structure can be declared inside other structure as a member, just like other member. A structure can also be defined inside another structure. Okay, so example, if we want to look into, now see, I'm defining employee structure. Okay, so where I'm storing his name and salary here. Okay, name, salary, and I want to store his address also. Okay, so address itself is not a single one. Address again composes different data. Okay, so that's why for storing that address, again I define another structure inside this employee structure. Okay, so how it can be defined like this struct address. Now you can directly define another structure inside this employee structure in this way. Struct address and begin the structure, and what members you want to store in this inner structure. This is called inner structure. Okay, so in address I want to store city, pin code and district name. These three things I want to store. Okay, so three are different data types here. Then I have defined with their names and data types. Okay, char city of 20 into pin code, then char district of 20. Okay, and close this inner structure with closing brace, and after the inner structure closing brace, then immediately you give this inner structure variable name here itself. Okay, so I am defining a address structure variable a here, then end this with a semicolon. Okay, so instead of writing in separate line, this is well possible here. Okay, so then I am ending this outer structure here. Then for outer structure also I am defining the variable e here directly, then end this with semicolon. Okay, so this way one structure can be defined in another structure. Okay, but you should remember when you define the inner structure variable must be defined here itself. Inner structure variable must be defined here itself. Okay, outer structure variable you can define here or you can define inside the main if you want. Okay, but the inner structure variable you must define here. Okay, now you can say this employee structure contains three members. What are those three members? Name, salary and A. Name is of which type? Character type. Salary is of which type? Float type. And what is A here? A is of which type? Struct address type. That means A is a variable whose data type is struct address. That means it is a structure. Okay, so that's why this is called nested structure. In one structure, employee structure, you are defining address structure, nested structure. This is first way of defining. No, sir, I am not interested to define one structure inside. I want to define them separately so that I can use individually these two structures. That is also possible. The second method, if you look into, now see, first I am defining my address structure here separately. Okay, so struct address, char city of 20, pin code and district. Then end this with a closing brace followed by semicolon. This is my address structure. Now I am defining employee structure here. Struct employee, char name of 30, float salary. Then now I can create a variable of this address structure here. Okay, so how I can define a member for this address structure? Struct address space A. Then end this semicolon with semicolon. Okay, so now A is also a member. Now see, there are three members in employee: name, salary, and A. Where A is a member whose data type is struct address type. Okay, so this is another way, second way of defining one structure in another structure. Okay, the advantage is you can use this address structure some other place also, because this is individual one. And you made this address structure as a member of this employee structure here. You can also use in some other structure also. And for employee structure, now I can create a variable like this: struct employee E. Struct employee E I can create. Okay, so now for E, the memory is allocated. So how much memory is allocated for E? If you see the memory diagram of E, now I'll show this memory diagram for E here. Now this is the memory for E. E contains three members. Okay, so just try to understand the concept here, nested structures. Now this is the memory allocated for E. Okay, now see here. Okay, so struct employee E, when you say, now for name, salary and A, memory is allocated. So for name 30 bytes, and for salary this is 4 bytes, and for A remaining 20, 20, 40 and plus 4, 44 bytes will be allocated for A. Okay, so that means first 30 bytes, now see here. Okay, so assume this is first 30 bytes. Okay, so 30 bytes will be allocated for a name field. Okay, so the next 4 bytes will be allocated for a salary here. This is salary. Okay, and then next 44 bytes will be allocated for a E. And this is third member A. This is how the memory is allocated for a E. Just see, observe here. So E contains three members: name, salary, and A. Okay, now this is the memory allocated for E: name, salary, and A. 30 bytes for name, 4 bytes for salary, and 44 bytes for A. Okay, but this A is not again a single value. A is not again a single member here. A is a structure member. So that means again this A is divided into three parts: city, pin code, and district. Okay, so if you look into the diagram, this A again contains three parts like this. Okay, now this is the memory allocated for this A. Now this is how the entire memory is split into three parts. Okay, so then this is 20 bytes here, then 4 bytes here, then 20 bytes. Okay, so then this first member is city. Okay, so here this is 20 bytes. Then the second one is pin code, and this is district. This is 4 bytes. 4 bytes for this, and again 20 bytes for district. Okay, so like this. Now from here, just observe here. From here to here, this is total 44 bytes. Yes or no? This is 44 bytes from here to here. So then this 44 bytes is again split into three parts like city, pin code and district. Okay. Now how do we access individual members? E dot name, E dot salary. Okay. So then E dot A, but A is not a single value here. Okay. So again A contains city, pin code and district. So how we access this A, this city here? So then we'll say E dot A dot city. We use dot operator two times. E dot A dot city. Okay. So similarly, how we access pin code? E dot A dot pin code. E dot A dot pin code. Okay. So how we access this district here? Similar way. Okay. So E dot A dot district. Like this. Okay. So the inner structure members can be accessed using the dot operator twice. We use the dot operator twice here. Okay. So you know A is a structure. Structure members, how you can access A dot city, A dot pin code, A dot district. But A is a member of another structure E. So how A can be accessed? E dot A. E dot A dot city, E dot A dot pin code, E dot A dot district. Okay. So this way the inner structure members can be accessed. Okay. So here outer structure contains only two members, E dot name, E dot salary. Directly you can access. Okay. But when it comes to A, again it is divided into three parts. So that's why we use this notation: E dot A dot city, E dot A dot pin code, E dot A dot district. Okay. Now what is the total memory allocated for this E? 30 plus 4 plus 44. Okay. 44 plus 4, 48 plus 30. Okay. So that means what is the total memory allocated for E? 44 plus 30, 78. Okay. So total 78 bytes of memory is allocated for this E. And this 78 bytes divided into three parts like this: 34 and 44. Again 44 divided into three parts like this. Clear? Okay. Now if we go back to this second method of defining, okay, so this is how we define structures individually, and we make this first structure as member of a second structure. And please remember, when you are making this first structure as a member of second structure, you must define this first structure first. Address structure must be defined first, then employee structure should be defined. If you define employee structure first, then address structure next, by the time the control comes here, then it don't know where is address structure. That's why it gives error. Okay, so we should define address structure first, then make that address structure as member of a employee structure. Then you won't get any error. Otherwise, you will get an error. Now we'll write a simple program demonstrating nested structure or structure within another structure. Okay, so you know, include the header file, then define the first structure here. So you know how to define address structure, city, pin code and district. Define the address structure, city, pin code and district. Okay, so close this with a semicolon. Okay, so then next define employee structure. Then inside the employee structure, name field and salary. Then I am making the first structure as a member, struct address A. Okay, so then close this with a closing brace followed by semicolon. Okay, now this is how the two structures can be defined separately after the header file. Okay, right? So now define the main function. Now inside the main, create a variable for the second structure, employee structure. So struct employee E. Okay, so when you define struct employee E, as I said, the memory is allocated for E like this. 78 bytes of memory is allocated for E in this way, and garbage values will be stored. Okay, so this all split we are doing for our convenience, but Memory is sequential collection. Okay, so compiler knows from which point to which point it is name field, from which point to which point it is salary, and it is city pin code. Okay, so internally compiler knows all these conventions. Okay, for our understanding, we are drawing this memory diagram in this way. Oh, 78 bytes. Okay, right. So once we define the variable struct employee, okay, so empty memory is allocated. Now you can ask the user to enter employee details. What details? Name, salary, city, pin code, and district name. You should pass these values because in the same order he should enter. Otherwise, if there is any mismatch, immediately compiler gives error. Okay, so one-to-one mapping will be done and stored in the same order. So that's why you should mention the order of values: name, salary, city, pin code, and district name. Okay, so now using scanf function, read them carefully. Okay, so first one name, percentage yes. Second one salary, floating point, percentage f. Next city, string, percentage yes. Next pin code, integer, percentage d. Next district name, string, percentage yes. And where to store them? And clearly mentioned. So in the address of e.name. So for strings, no need of writing this ampersand, but for maintaining this uniformity, I am using this ampersand for all the members here. Okay, so address of e.name. Then next one is e.salary, address of e.salary. And now see here. So where to store this city? How to access this city? Address of e.a.city. How to access pin code? Address of e.a.pin code and address of e.a.district. Okay, so then these values, whatever values you enter, they will be stored in a memory. Okay, so then now you print employee details separately. Okay, so once you store inside the memory, now you can access using the same array structure notation dot operator. Okay, so I'm printing name of the employee. How can I access name? E dot name. Then his salary, E dot salary I can access. Then city. Now how can I access city? E dot A dot city. Then pin code, E dot A dot pin code, and district name if you want to print, then how I can access E dot A dot district. Okay, so then return 0, close the main. Okay, so this way the employee details can be printed onto the screen. Okay, so nested structures. Please remember, when you are using nested structures, you need to use dot operator twice: E dot A dot city, E dot A dot pin code, and E dot A dot district. Based on the member names you define. My members are city, pin code, districts. That's why I'm using these names here. Okay, right? So just let me execute this program. So the execution of this program, whether it works or not, you should confirm. Then main function, you copy here and paste the main here. Okay, right? So this is address structure here and this is employee structure here. So let me save the program so that nested structure. Okay, so I give the name as nested struct.c. Okay, now you can see the color change and you can easily distinguish between two structures. Struct address up to here, struct employee. Okay, now I made struct address A as a member in this. Okay, so then I am defining a struct employee E here. Now I am asking the user. Okay, so these double quotes creates problem. No, I am changing this double quotes here itself. Okay, so here I use a new line, that's why I'm getting error here. Yes, okay, so pin code and district name. Then end this with a semicolon. Okay, right? So similarly scanf and change this double quotes here. Percentage yes, percentage f here. Okay, so here it is e dot name, then it is e dot salary, then e dot a dot city, then e dot a dot pin code, then e dot a dot district. Okay, so end this with a semicolon. Okay, so then I am printing those details here. Okay, so just see details of employee heading I am printing here. Okay, so then I can access each member using the dot operator this way. Remove the semicolons because these, sorry, double quotes. Now you can see district name is equal to percentage string. Okay, so e dot a dot district. Okay, so now save the program. Okay, so now build the program. So any errors? No, zero errors. Okay, right. So now I run the program. Now you can see enter employee details, name, salary, city, pin code and district name. So in the same order we should enter. Okay, so employee name something like Ramesh. Okay, so then salary 1234.75 I enter. Okay, so then pin code 506 something like 001 I enter. Okay, sorry, city I need to enter now. So city is Anamkonda. Okay, so then pin code I enter as 506001, then district name is Warangal. Okay, so then it reads all these details and stores in a that variable e, and from that variable we are printing these details. Now see here, details of employee, name is equal to Ramesh, salary is equal to this, and city is, what is this city name gone wrong. Okay, instead of dot I kept comma here, that's why city it has taken as 75, pin code everything goes wrong. Okay, so let us run this program again. Now name is Ramesh. Okay, so salary 12345.75. now it takes it as a, then city is HNK, I'm typing in short. Okay, so pin code is 506009 I'm writing. Okay, so district is WGL I'm typing. Now you can see it printed correctly. Okay, so name is equal to Ramesh, salary is 1234.75, city is HNK, pin code 506009 and district name WGL. Okay, so like this, if you enter the data in the correct order, then it takes, otherwise there will be a mismatch of data, and sometimes lower data type will be converted to higher data type and it accepts such a data sometimes. Otherwise, sometimes if it is not matching, then it gives error. Okay, so this is about a array of structures. Sorry, array of structures, nested structures. Okay, so all these concepts today we discuss.